Hello everyone, welcome to you. And today now I'm going to start unit third of basic mechanical engineering. And this is lecture one of this unit. And this unit belongs to automobile and IC engine. So first I'm going to cover IC engine. So let's see one by one. So first you can see the reference book. Here you can see the reference book, that is internal combustion engine by V Ganeshan, and mostly I have followed this book, and internal combustion engine by Mathur and Sharma, and similar engineering thermodynamics by PK Nag. So these three are the reference and textbook for this particular course. So mostly I followed internal combustion engine by V Ganeshan. Okay, so let's see, this chapter actually belongs to engine, and especially internal combustion engine, and of course we also see what is external combustion engine. So both engine we see. So this actually part of this unit third, I will cover around in 4 lectures, correct? So this is an introductory lecture in which I cover basic definition of engine, heat engine, their types, and the external combustion engine, internal combustion engine, and their types and their principle, working principle, along with difference. Okay. So let's see one by one. So first you can see here that is internal combustion engine, sorry, engine. So engine is nothing but it refers to the device which transform one form of energy. It is a device which transform one form of energy into another form of energy. Like if you have a fuel and if you burn it, then obviously the chemical energy after burning is converted into heat energy. Is it right? And similarly heat energy is further converted into some mechanical work. So a device which transform these types of energies from one form to another form, then this is called as a engine. Is it right? Next, very famous, that is heat engine. So heat engine is nothing but it is already named, that is heat and engine, correct? So this is a device. It is a device basically which transform chemical energy of a fuel into a thermal energy. Obviously thermal energy is nothing but this is called heat. This is called heat. Is it right? And utilizes this thermal energy to perform some useful work. Is it right? So work is also another form of energy. So basically if I talk about energy, then here we have two types of energy, that is in terms of heat and in terms of work. Is it right? So mutual conversion of heat into work, this is the main thing. And a device which deals with this transformation from heat to work or work to heat, or basically from heat to work only, in this direction. Here we have a direction, correct? This device can only transform heat to work only. Is it right? So heat to work, then this device is called as heat engine. Are you getting this? So heat engine is nothing but it is a device. First, initially it convert chemical energy into heat energy, and this further heat energy is transformed into work. Is it right? So this device is called as heat engine. Is it right? And this heat engine basically used for many purposes. It is used for converting, it is used for producing, it is used for running the automobile. Is it right? This device, this heat engine basically utilizes in automobile to run the vehicle, and it is also utilized to generate electricity in the power plant. Yes or no? And of course this device is also further utilized in industries also for many purposes. Basically we need to generate electricity, and once you generate the electricity, then you can use this electricity for many applications. And like just like in our household application, if I talk about, then in our household application you can see this electricity is basically used to run the fan, used to light the home. Is it right? You can even charge the mobile phone. Is it right? You can run the TV. So many applications we have. Like you can also use a heater to heat the water. Yes or no? And even we can cook the food with the help of this electricity, obviously this electricity is further converted into heat. So many applications we have. So when I talk about heat engine, then this engine basically used to run the vehicle, is it right? This basically engine either run to vehicle or it can generate the electricity. These are the two main purpose of heat engine. Okay, next, basically here we have two categories of heat engine. One is external combustion engine, another one is internal combustion. So if I talk about external combustion engine, means a engine in which engine in which uh, combustion combustion of fuel combustion of fuel takes place combustion of fuel takes place outside the engine, is it right? Outside the engine, is it right? So this is called external combustion engine. And if combustion, or simply if I say if a combustion means burning of fuel, is it right? Combustion means burning of fuel, like a coal or a, you can say, petrol, diesel, or a gas even. If combustion takes place, if combustion of fuel takes place outside the engine, then it is called as external combustion engine. And if combustion takes place inside the engine, then it is called as internal combustion engine. This is the basic difference between internal combustion engine and external combustion engine, is it right? And if I talk about fuel, then obviously here we can use either a coal, we can use, is it right, we can use gas, natural gas, like, or we can use petrol, diesel, etc., is it right? Correct. And in internal combustion engine we use only either liquid fuel, like either we can use petrol or diesel, is it right? And even we can use gas, like if we can use LPG gas or we can use CNG gas, is it right? So these are the fuels that can be used in internal combustion engine. And in external combustion engine, obviously we can use solid fuel, is it right, like a coal. We can use gaseous fuel, like a you can say LPG gas or CNG gas, is it right? And we can use liquid, like a petrol or a diesel, is it right? All kind of fuel can be used in an external combustion engine. But internal combustion engine, basically we use either liquid as a fuel and gaseous fuel. Okay, these two fuels can be used, correct? Next, this is the detailed classification of heat engine. So basically, obviously, we know that heat engine we have two types, that is external combustion engine and internal combustion engine. Okay, and in internal combustion engine, either we have rotary engine or reciprocating engine. Rotary engine means in which the rotation, the heat energy is converted into a rotatory motion first, and this rotatory motion is further used to generate either work or for electricity. Is it right? Correct. And in reciprocating engine, basically the piston can reciprocate inside the cylinder, and this reciprocating, or we can say linear motion, will be further converted into rotary motion, and that rotary motion is further utilized for the either for the direct running of the vehicle or for the electricity generation. Is it right? So IC engine, here we have two types, that is either rotary engine or reciprocating engine. And if I talk about rotary engine, of course, then here we have turbine open cycle gas turbine or Wankel engine. Is it right? And in reciprocating engine, here we have gasoline engine and diesel engine. Gasoline means petrol engine or diesel engine. Is that right? Correct. So this is the detail classification of IC engine, and of course we only deal with this reciprocating engine only, and I'm not covering this rotary engine. Is that right? Next, if I talk about external combustion engine, then again here we have either it is reciprocating engine or rotary engine. Then reciprocating engine was used for running the steam engine. Okay, steam engine, which for the which it was used for in the train. Obviously you have seen in the Gadar movie. Okay, old trains. And Stirling engine, this is another reciprocating engine, and this Stirling engine, it was used for mechanical work only. Is it right? And next, rotary engine, that is steam turbine and closed cycle gas turbine. So these are the engines which are nowadays we use, but these two engines are obsolete. Correct? These engines cannot be used. Okay, but these engines like steam turbines we can use to generate electricity in thermal power plant or in a nuclear power plant, and similarly closed cycle gas turbines are also used. Is it right? Okay, next, you can see the external combustion engine. This is the external combustion engine. You can see this engine is basically used, it was used in the train railways. Okay, you can see that this railway chuk chuk rail gadi. Okay, so in this, basically we have a combustion chamber. This is a combustion chamber, and this is a water tank. Is it right? And this is a water tank, and you can see this dark color, green color shows water, and this light yellow colors represents steam. And now when you burn the coal inside the combustion chamber, then because of this combustion, the heat energy will be liberated, and this heat energy is further utilized to produce a steam. Is it right? So obviously, just above this combustion chamber we have a heating coils from which we supply water, so that water get converted into steam. And once the steam will produced, this steam is further utilized. You can see when you pass this steam from this engine reciprocating system, then when it passes through this piston cylinder arrangement, then it pushes the piston. Then obviously this connecting rod can reciprocate along this direction, and because of this reciprocating motion, here we have a crank which converts this reciprocating. This is a crank. Is it right? This is a crank, and this is a crankshaft and connecting rod. Is it right? And this is a piston, and this is a cylinder. Okay, so due to the steam pressure, obviously this steam is uh, present at a high pressure, and when you pass this high pressure steam from the cylinder, then this steam get expanded, and because of this expansion of the gas, this piston can reciprocate along this direction, and due to the reciprocating motion of the piston, this connecting rod is also reciprocate, and this is connected with the crankshaft. And once the reciprocating takes place, then because of that the crankshaft starts rotating, and once it get rotating, then because of this rotation you just run the train. Is it right? So this is typical external combustion engine based railway. Okay, so this is called external combustion engine. So now the question is, why it is called external combustion engine? So you can see basically the energy which thermal energy which converts mechanical energy takes place inside this piston cylinder arrangement. And in this piston cylinder arrangement, there is no combustion. The combustion takes place outside this piston cylinder arrangement. That's why this is called external combustion engine. Is it right? Are you getting my point? since here the combustion takes place outside this piston cylinder arrangement, that's why this is called external combustion engine. And this is the first external combustion engine which is developed by the Stirling. Is it right? Next, this is the internal combustion engine. So you can see the internal combustion engine. This is a piston. This is a piston. And you can see obviously this is a cylinder. And this is a connecting rod. This brown part is a connecting rod. And this is a crank. Is that right? Crankshaft actually. This is a crankshaft. And this is a crank. And of course, these are the balls. These are the two valves. Inlet and outlet valve. Okay. So of course, and these obviously from here the fuel air mixture can enter into the piston, the cylinder, and once it get fired, and of course here we have a spark plug. This is a spark plug. Is it right? So when you spark this fuel, I'm not talking about entire operation of this internal combustion. I'm just talking about the basic parts and the basic process. Okay. So once this fuel enter into this cylinder, then of course by the reciprocating motion of this piston, the first compression takes place. Once it get compressed, then with the help of the spark plug, when you spark it, when you provide a spark, then because of that the entire fuel inside this piston cylinder arrangement burn, and because of this burning huge pressure will be generated, and because of that huge pressure it pushes the piston so that this piston can move down. Yes or no? And once it get moved down, then in this system we also have a flywheel which stored the energy, and of course this energy is further utilized in the remaining strokes. Is it right? So obviously here you burn the fuel, and because of that pressure, very huge pressure will generated, and once it get generated, then this huge pressure gas may expand, and because of that expansion of the gas, this piston can move, or you can say this piston can reciprocate, and this reciprocating motion is further utilized to run the vehicle. Is it right? And of course when it reciprocates, then this power, reciprocating power, is transferred from this piston to connecting rod, and from connecting rod to crank, and then from crank to crankshaft. Is it right? And of course when this connecting rod can move up and down, is it right, then of course the crank can rotates. Yes or no? And once the crank can rotates, then obviously this is connected with the crankshaft, then crankshaft is also start rotating, and because of that rotatory motion we will get the heat energy into a mechanical work. Okay. So this is called internal combustion engine. Now the question is why it is called internal combustion engine. The previous one was the external combustion engine. So you can see this is a piston cylinder arrangement, and here the combustion of the fuel takes place inside the cylinder. That's why this is called as internal combustion engine. Is it right? Since in this the combustion takes place inside the cylinder, that's why this is called as internal combustion engine. But in the previous one, since the combustion takes place outside this piston cylinder arrangement, that's why it was called as a external combustion engine. So you can see here in internal combustion engine is a type of heat engine in which the combustion of the fuel takes place inside the engine cylinder itself. That due to this the high pressure and high temperature gases produced, and once it get produced, then obviously these gases may start expansion, and because of that expansion the mechanical work takes place. Okay. So this is the basic principle of internal combustion engine. So you can see here the chemical energy of the fuel will be converted into thermal energy due to the combustion or due to the burning of the fuel. Like if you see, if you have a coal and if you burn that coal, and if you put a pan of water, then that water get heated. Yes or no? Is that right? So what will happen here? Obviously due to the presence of oxygen, the carbon of the coal may burn. Is that right? And due to the burning, their chemical energy will be converted into heat energy, and that heat energy is further utilized in some another application. Okay. So similar thing is happening here. The chemical energy of the fuel means, but either it is a petrol or a diesel, or even a gas like a natural gas or LPG gas, When you burn it, then after burning or after combustion, the chemical energy will be converted into heat energy, or you can say thermal energy, and this thermal energy is further converted into mechanical energy. And where we will get mechanical? So you can see obviously here, when you burn the fuel, then chemical energy will be transformed into heat energy. And because of this heat energy, when this piston reciprocates, then at the crankshaft here we get a mechanical power or a mechanical energy. Is that right? So this is the basic principle of internal combustion engine. Is that right? So chemical energy of the fuel transformed to thermal energy, and thermal energy is transformed into mechanical energy. Is that right? Now, if I talk about the application, then of course this internal combustion is used obviously in the modern automobiles like cars, bike, trucks, buses, and it is also used for power generation like in a DC set. Is it right? And it is also used in marine engines like for running ships or boats. We can use internal combustion engine. Aviation, of course, the aircraft, small aircrafts are also run by this engine. And but of course the commercial and big size aircraft basically run by the not internal combustion engine, you can say it is a jet engines. Okay. And industrial pumps uses industrial applications, we have several applications like pumps, compressors, and even in the roadside, if you see the puncture wala, they uses compressor. Is that right? Then that compressor is also run by the IC engine. Is that right? So many application nearby us, nearby our daily life, we can see the application of internal combustion engine. Like you are driving either bike or car, then you can see these bike cars are run by the IC engine. And of course the electricity generator DG set is also run by the IC engine. And of course you can see the compressor, this is also run by the IC engine. And even many agriculture machineries, small machineries, are also run by the IC engine. So we have vast application of IC engine. Is it right? And now if I talk about the advantage, then of course its size is less and it will produce high power, and its a power to weight ratio is also very high. Power to weight ratio means per kilowatt. If I talk about the size of the engine, then the size of the engine is very small. IC engine is very small. Is it right? That's why power to weight ratio is very high. And of course due to the compact size, it can be used in our vehicle weight is also reduces, and hence it will produces more fuel economy. Is it right? Lighter the weight of the engine, better will be the fuel economy. Remember this point. Lighter the weight, better will be the fuel economy. Okay. And that's why nowadays we are developing such material which has high strength and low weight. Is it right? So that we will obtain higher fuel efficiency. Is it right? And quick start and easy operation, these are the some advantages, and obviously many more advantages are also there. And now apart from this advantage, we have some disadvantages like limited efficiency. Of course every IC engine cannot produce more than 40% efficiency. It is ranges around 30 to 40%. And high pollution, even the word pollution may the you can say environmental pollution. If I talk about environmental pollution, then automobile plays a very wide, very means a crucial role. Is it right? Most of the population is generated by the automobile only. Is it right? So why? Because automobile produces carbon monoxide, nitrous oxide, unburned hydrocarbons. Is it right? So due to, and even sulfur oxide and many more. Okay, because of these pollutants, the very huge pollution takes place. Is it right? So if I talk about the global warming, this is the main reason behind the global warming. Automobile is the main key. It plays a very you can say a crucial role in the global warming. Is it right? So if we reduce the fuel consumption, if we reduce the burning of the fuel, petrol, application of diesel fuel or coal, we can reduce the we can say pollution. Yes or no? And once we reduce the pollution, then obviously the global warming may also reduces. Is that right? So that's why nowadays engineers developed many new fuels which are environment friendly, like a hydrogen fuel, like ethanol fuel. Is that right? Which are obtained from the natural sources. Correct? And even electric vehicle is also one of the major development on the field of this automobile, is it right? But of course, the electric vehicle may consider as a pollutant free vehicle when the electricity will be generated by the some renewable source of energy, or we can say green energy, which not produces any pollution, is it right? And it requires frequent maintenance. Obviously, you know, if you run the bike, then you need to do every after 3 months 4 months you need to go for the service station, okay? So these are the some advantage, disadvantage, and applications of IC engine. And now you can see some historical background of IC engine. So first commercial successful IC engine was developed at 1860. It is developed by Etienne Lenoir. Is it right? He was the inventor of this engine, and it was a first commercial engine, internal combustion engine. Is it right? And Etienne Lenoir was a Belgium born French engineer who developed the first commercial engine, and his engine uses illuminating gas as a fuel and operating on a two-stroke cycle. Okay, this engine is basically worked on two-stroke, and it is basically run by the gas as a used as a fuel. Okay, and while his engine was not very fuel efficient, obviously it was, even if I talk about some data, then by for producing 0.35 kilowatt, a very big size engine is required, is it right? 0.35 kilowatt, which is very very less energy. Nowadays you can see the your small engine can produce huge amount of energy, is it right? But yes, of course, because of this small development, you can not a small, there's a very big development. Because of that development, nowadays vehicle can run, is it right? So it was a very very important development, uh, or you can say invention done by the Etienne Linear, okay? And in 1862, Linear adopted his engine to run on a liquid fuel that is called as a first automobile powered and internal combustion engine. Oh, is it right? And after that, Nicholas Otto is one of the another engineer who developed four-stroke cycle engine, which were further used for running the vehicle. And nowadays, in the modern automobile, we use four-stroke cycle engine. Is it right? Either it is petrol-based fuel engine, petrol-based engine, or a diesel-based engine. So, of course, Nicholas Otto was developed petrol-based four-stroke engine. Okay, and you can see the Nicholas Otto. He's the Nicholas Otto. He was invented four-stroke petrol engine at 1867. Uh, this was the engine, okay, and this is first internal combustion engine to run the petroleum based fuel. Is it right? This is the first engine which run on the basis of petroleum fuel, and the Otto engine is a four-stroke internal combustion, and the four-stroke of the Otto cycle are intake compression power. And of course, in the later on discussion, I will tell you what is four-stroke, what is two-stroke, what is the difference between them, and what is petrol engine, what is diesel engine, and what is the difference between them. Many details I will discuss on later on lectures. And of course, this type of engine is still used. You can say this type, not this type, this is the first invention, but many modifications done, and nowadays we use a very small engine, is it right, which works on this principle only, is it right? And even you can say for the modern automobile, he was the inventor, is it right, which invent the four-stroke petrol engine, is it right? And you can say this is the first automobile, is it right? This is the first automobile, you can say. And this first automobile made by the Carl Benz, this is it right, Carl Benz, okay. And it is a one cylinder two stroke unit which run the first time on the New York Ave at 1879, and Benz had so much commercial success with this engine. And now you can see the Benz cars, okay, and that he was able to devote more time to his dream and crafting this light-weighted car powered by gasoline engine. And after that, obviously, you can see this is a vehicle. In this, the engine, body, chassis, everything is a single unit. Is it right? And this vehicle can run. Is it right? Automatically with the help of this engine. So this is the very big development. And after that, nowadays you can see the so many engines, so many cars, bikes, and so many vehicles. Okay. And next, let's see is little bit details information about external combustion engine. So this is external combustion engine. You already know this is a combustion chamber. This is a water tank, and this is a steam tank. And of course, when you heat this water, then it will be converted into steam at high pressure. And this high pressure steam is further utilized to run this piston cylinder arrangement. And due to this, the reciprocating motion takes place. And of course, this is connected with the crank. Then this reciprocating motion will be converted into a rotary motion, and that rotary motion is further used to run the train. Okay. And next, basic principle again, this it is remains same. In this, the fuel is burned outside the engine. Obviously the fuel combustion takes place outside the engine, and due to this the heat will be generated, and this heat is transformed to another working fluid, that is water, which is converted into steam. So you can see here, water, in this water will be converted into, means water into steam. Is it right? It means this heat which is produced by the combustion of the fuel directly cannot be utilized to run the vehicle, but yes, first when you burn the fuel, then it will produce as heat, and this heat is further utilized to convert water into steam. And of course its pressure and temperature is high as compared to water, and this pressurized fuel is further used to expand inside the piston cylinder arrangement, so that this pressure energy will be converted into kinetic energy. Is it right? So like this you can transform this fuel energy into a mechanical work. Is it right? So this is the basic principle of internal external combustion engine. So are you getting this? So obviously you have a chemical energy. Is it right? And this chemical energy is further used to convert heat energy, and this heat energy used to convert water into steam. Is it right? And once this water is converted into steam, then this steam can expand it inside the piston cylinder arrangement. So here the pressure energy is basically converting into a kinetic energy, and this kinetic energy used to run the vehicle. Is it right? Are you getting my point? So this is the basic principle of external combustion engine. And if I talk about example, then steam engine, steam turbine, Stirling engine, hot air engine, these are the engines which are run by the external combustion engine principle. Is it right? Nowadays we use steam engine. Nowadays we cannot use this steam engine which is used for running the locomotives, obviously the railways. Now we cannot use this. We now in a modern era we use electric engine. And steam turbine, of course nowadays we use this steam turbine is still we are using to run the steam power plant, thermal power plant, to produce electricity. Is it right? And if I talk about application, then thermal power plants can be run on the basis of this principle. Marine propulsion, steam ships, industrial power in earlier centuries, but nowadays we are not using this. Nuclear power plant, of course, thermal power plant and nuclear power plant. These are the major application in a modern era. Is it right? And if I talk about advantage, can uses a wide variety of fuel. Like you can see, like we can use coal, we can use wood, we can use nuclear energy. Many varieties of energies can be used to run the engine. Okay. Smoother running due to the steady external combustion, less vibration compared to IC engine. So these are the some advantages of external combustion engine. But yes, apart from this advantage, many disadvantages also there. Like this engine is a very bulky and heavy engine. Is it right? Very bulky and heavy engine, so it cannot be directly used to run the vehicle. Is it right? Or a locomotive. And obviously it is a slow start engine. Obviously if you burn the coal, then the heat generation rate will be slower. Is that right? That's why this engine is slower. And lower overall efficiency as compared to ICE engine. Its efficiency, overall efficiency is very low, around 20% efficiency. So it means 80% of energy is completely wasted. And if you waste this energy, then obviously global warming may causes. Okay. And it require more space and higher maintenance. Is it right? So these are the some advantage and disadvantage of external combustion engines. And let's see the difference between this external combustion engine and internal combustion engine, and after that I will summarize this lecture. So obviously in IC engine, working fluid takes part in a combustion, fluid takes part in combustion process. Working fluid does not take part in a combustion process. Is it right? It means internal in a IC engine, fuel is directly burned and it will produces work. But in external combustion, it cannot be used directly to produce the work. Okay. First, when you burn the fuel, then it will produces steam, and that steam is further utilized to work, produces the mechanical work. Okay. And heat of combustion is transformed directly from the working fluid, and heat of combustion transformed to a second fluid which act as a working fluid. Means this fuel energy directly cannot be used to run the engine. Okay. And high power to weight ratio, of course I told you already, in IC engine we have very high power to weight ratio, means for producing unit kilowatt power, small size engine required in IC engine, but in case of external combustion engine, a big size engine required. Okay. Absence of auxiliary apparatus like a boiler or condenser, these things are not required. But yes, in induction combustion engine we need boiler, condenser. Why we need condenser? Obviously you can see in the previous slide, you can see when you burn this coal, then obviously this heat energy is converting water into steam. Then of course after expansion inside the piston, we need to collect this steam again, and again it will be converted into water. Yes or no? So from conversion of steam to water, from gas to liquid, we need a device which is called as condenser. Is it right? That condenser further condense the gas into a water. That then again we use this same water to operate this system. Is it right? In a cyclic manner. Otherwise, huge amount of water required. Is it right? And of course, next IC engine overall efficiency is very high as compared to external combustion engine, around 35 to 40%. Is that right? But here less than up to 20%, not more than 20%. Heat rejection is easier. Yes, of course. If you see the IC engine in your bike engine, then obviously some fins are provided over the engine surface, and because of that, heat is directly exposed to the atmosphere. Yes or no? But for the external combustion engine, we need chimney. You can say we need this chimney. Is it right? Then you can transfer the burned combustible fuel and heat outside the engine. Is it right? But this external devices are not required. Is it right? Separate device is required for heat rejection, that is chimney. Okay. And self starting, yes, in IC engine self starting is possible, but here self starting is not possible. And even to run the IC engine, to start the IC engine, initial torque will be very high, and IC engine require high grade of fuel, of course, like petrol, diesel or gasoline, gaseous fluid like natural gas or LPG gas. But yes, in an external combustion engine we can use coal, we can use nuclear, we can use liquid like a petrol, diesel, we can use gas like LPG LPG gas or CNG gas. Now you can see the application. Of course it is used in automobile, transport vehicle, aircraft, etc. And this is used in steam power plant and gas turbine plants. Mainly these two main major consumer of this is external combustion engine. Is it right? And now you can see the in internal combustion engine, uh, let me see. So rest of the part I will discuss in the tomorrow next lecture. Okay. So I think it is enough for today's lecture. The rest of the part I will discuss in the next lecture. Okay. So thank you. And of course, this is the introductory part where you see what is IC engine, what is EC engine, what is the difference between IC engine and EC engine, what are the applications, advantages, disadvantages. Okay. So I hope you will understand this basic fundamental of IC engine and introduction of internal and external combustion engine. So now I'm going to end this session. Thank you and good day to all of you guys.